Welcome to this, our fourth lecture. We're continuing to learn about AutoCAD and structural drafting for civil engineers. We're going to be continuing today now looking at concrete layouts and finishing off our drawings. The drawings we started off in the first few lessons, what we might need to add to those to get to a stage where they can be built. So following on from our first lecture, or first lesson, we learned about AutoCAD's interface. Second lesson, we're setting out the building and general drawing tools. Third lesson really focused on steelwork and how to draw steelwork. The fourth lesson now, we're going to focus more on the tools to complete our layout, especially concrete layouts today, and what you need to show on your concrete layouts, base schedules, column schedules, the likes, tying concrete to steelwork, and then also, hopefully at some time, we're going to look at some overlays and layers, how we can overlay concrete on steel to check layouts. So let's go back to AutoCAD and get going. All right. So we completed this layout last time, all our steel work, and now we can move on to our concrete to put together everything that the building contractor, the concrete contractor or civils guy, whoever it is, the information he needs to build this building. Firstly, we can have a look at foundations. A foundation drawing might look like this, which shows all the different foundations that occur. And with the foundation drawing, there's various information you have to give it. But before we get to that stage, the way you could draw this would be more or less the same as we learned in the second and third lessons, by simply creating one column or one base, and then creating a block of this, and then creating an array across, or mirroring it. Especially would it be useful because there's so much repetition is, you could create a block with the next bay of brickwork, and then repeat that throughout, so you can carry the brickwork out. And the brickwork you could otherwise draw in all the columns, offset two rectangles, draw it from this point here to the far corner and offset it by 115 mils each way, and then go and just trim the lines out between the columns. So you could relatively quickly get that. You need to show all your strip footings. There we go, but 600 by 250 strip footings. Normally you could go a bit thinner than that, maybe 230, 200, depending on the brickwork. That was just done because it matched the 250 thickness of the bases. But now let's have a look at our foundation layout. What we need to do is give the contractor a schedule so he knows what details to associate with each base. For instance, here we've got base type A. If we go to our schedule here, base and plinth legend, base type A is at 2.1 by 1.2 by 250 mils thick. The top level varies, and we give top levels here. Grid line 1 is such and such a level, grid line 2 such and such, grid line 3 such and such. The steel column on top size, plinth size, top level, etc. So we provide all the information needed there to be able to give the contractor a general idea. I'm going to go to a completed drawing now of a structure that's being built or been built. And here we show the foundation layout of a full warehouse. You can see this is a much bigger, much more complicated warehouse. So you've got various bases here. So you have type B1, B2, B3, and then all the different sizes, and also the number of. That's very useful when you're doing your bending schedules, the rebar schedules, to know in how many schedules of each type you have to produce. Above that, we've got a column schedule, so you can even tell them what type of columns they are, whether they're concrete, steel, etc. So provide all those different information. C1 for concrete, S1 for steel, but this really depends. Footing schedules, there's strip footings all the way around, even a wall schedule. So these are various bits of information that can be provided. Now this layout was produced in Revit, so you can see it's got a slightly different style to AutoCAD, but you could produce something very similar to this in AutoCAD. If you go to a particular base, you can see here this is the Revit style. It's got a base B1 with a column C3 on top. TOC, top of concrete, is at 63.315 meters. So you provide the top of concrete level so that the contractor knows where to pour his concrete up to, and also then he can subtract the thickness of the base to get to the bottom of the excavation. But when you provide levels, you always provide a top of concrete, a TOC level for concrete works. The same thing if you're doing a concrete slab, when you provide the top of concrete level for anything, and you go around and you provide various concrete levels, foundations. That's, for instance, the F1 or wall type 1. Sometimes you just label the wall directly. So those are the general types of details you'd need. A different way that's sometimes shown, this is a very, very big warehouse that was done. There we go, another base column and plinth legend with sizes, top levels, plinth size if it's got a bit, or if it's got a column size on top, and then the top level of the column, or you can say varies. So you need to provide all the information, and not just the base size, the top of concrete size, and then also what is the top of the column. Where does the column stop out at? Because the level that I showed you just now, this TOC, 63315, that's the top of the base level, and you might need to provide a separate drawing with the top of the column levels. I'm going to go to a drawing here, and here we go. This providing some top of concrete levels of the column. See, it's a column C1, 66715. So at least they know where to start the column, where to stop the column, and that helps provide all the information. So those are the general main details you would need to provide on the schedule. And with the tools you've learned in the first two lessons, you could quite easily go through and draw those. Draw them out. If you click on those, it gives you details. You can set them as a foundation level or concrete level, or layer, or whatever is required. So that's your general foundations done quite quickly. Just make sure you set the level very carefully, as discussed previously, so that you can clear all surfaces. I'm going to go back to our 3D model. If there's anything on top of this, make sure that it can go over the top, roads or brickwork, or that's not popping out the ground, this foundation. Otherwise, that also this foundation sits on competent soil material, so maybe this layer has to come further down. I'm going to go to a model while we're talking, and while we go back to AutoCAD, and load up another model, which has much different conditions, since we had to drop our foundations quite deep. Right, now back into AutoCAD, and back to our layers. Alright, so that was our foundation layer. This one also showed other things that went in. These were drainage lines that went underneath the building, those cyan lines. If you have anything at the same level as the foundation, you probably show it in your foundation drawing, even if it's a drawing on its own, just giving basic details, just to avoid clashes, so that you don't have the pipe going through the column. Okay, moving on then to a concrete drawing of a surface bed. This is a typical surface bed. Surface bed is another name for a floor. The details, though, you can see you could even use for a suspended slab or normal concrete floor up in the air. This is a 170 thick 30 MPa surface bed, giving the top of concrete. You normally draw an arrow from one side to the other, like that. So that tells the contractor that from there to there, that is the specification of this panel, the thickness, etc. And you provide probably layer works or specification regarding details. The layer work spec might look like that. That was a very, very heavy duty floor that had to be put in one factory. It's not normally as heavy duty as that. On this sort of surface bed, you'd have to denote saw cut joints, construction joints, put those all out. If you want to have a look at details, see Murray and Perry's book in Concrete Industrial Surface Beds on the Ground. Very good book in terms of floors, so that will guide you in terms of saw cut joints, layouts, construction joints, etc. What you normally do, though, for a concrete layout like this, where you've got all that information, have some typical details. This is a typical construction joint, and you can copy this from one drawing to a next. This I copied directly from that book I just mentioned, Murray and Perry's book. And a typical saw cut detail. Remember, saw cut is just a very neat crack, because you saw cut it, it weakens it in the cracks below. You come through and ream it out afterwards and seal it. So that's the sort of joint that it looks like. So that's a very neat crack. And that's what all these dotted lines are. Those are all saw cut joints. So we've got nice, neat, cracked panels. So it all looks beautiful on site, and we come through and seal those joints afterwards. Now, this model, there we go, should be loaded up. We can go into it. You can see these foundations were much deeper than the one we just had a look at. That was because of the geotechnical conditions on site, so we had to drop those. But also this has got a lot more concrete work, so what I'm going to do is just cut a section through this model, and you can start having a look at some of the details you might need to provide. From here we've got a beam, column, etc. Our little warehouse we've drawn, we didn't have to provide much in terms of that. But many jobs you'd have to provide slab details. For instance, what thickness is the slab? What's the details of this beam that goes around the side? What's the details of this beam? Is it an upstand beam, downstand, or this is both? This is an upstand beam there, so it sticks above the slab. This is a downstand beam below. You normally demarcate those upstand U/S, downstand D/S. and putting slope. This is a sloped slab in front, but normally you don't get that fancy. So yeah, you go through and start putting all those details on a concrete drawing if you had to. This is what that concrete drawing looks like. So I zoom in, and you can see, there we go, 450 by 510 deep beams. So you can put in beams all the way around. So you draw the slab out. There's your line going from one side to the other. You got labeled 255 thick RC, reinforced concrete slab, top of concrete such and such a level. There's a lot more complications on because we've got sleeves and services for the mechanical and firefighting and electrical work, so you've got to make sure that's all on. And yeah, then you can start putting in staircases and etc. If you go to the slab above, I don't know too much more. Right, there we've got plinths on top for the air conditioning units, holes for the various pipes that have to go through, and then you can start marking off 460 by 1025 upstand beam. You'll see a lot of these sizes in widths. They're those increments of 230, so 230, 460, etc. And then in depth increments of 85 mils, as we discussed previously, that those are standard brick courses, so brick widths of 115 skins and brick depths of 185 mils per course. Right, and eventually they can produce something like this. You wouldn't normally draw 3D in AutoCAD, this is from Revit. So you could go through and you'd need to give them all the details they need for these columns, beams, slabs, etc. to produce something, strip footings, and the likes. So that covers a lot then of what we've gone through now. Most of the drawing tools, fairly straightforward, just lines and dotted lines and layers and such. As for layers we discussed, there's a saw cut joint on the specific layer and various other things. Alright, so those are the details. Oh, these are at the corners. Let me just find a label for one of those. Oops, put a label here somewhere. These are just corner up. 2Y12s top and bottom, corner bars. Those will prevent cracks at the corner, so cast the slab. And with this column, this plinth sticking into it, it might crack there, so you put in corner bars. So that's a useful tool you use. And that now gives you a surface bed layout to make sure the panels are less than 4.5 meters apart, these saw cuts, but there's general guidelines that you should look at for doing these things. Now we've got all our concrete layers and all our steelwork together. We just need to make sure that they fit together. A couple of things that we might need to add to make sure that this interface is right. I'm going to actually can show you here. You need to make sure you've got posts for your roller shutter doors. These are posts. These are just open channels, actually quite lightweight, 3mm thick open channels. The detail work quite well. Normally, otherwise, you use cold formed lip channels. I'm just going to go to my layout there. Right. Go back to my layout. Go to this side. There we go. There's your parallel flange channel that would be bolted to the surface bed or bolted to the foundation. You can normally chemical anchor this, so you can tie that and then make sure this line, just be careful, sometimes you want to tie this up with the front of the girths such that then your sheeting fixes to this. Otherwise you move it backwards and tie it in with the brickwork, this PFC, parallel flange channel steel, and then if it's back from the girt, what you need to make sure there's a little angle or something in the front that you can fix steelwork to. If you've got doors, you can do it with cold formed lip channels. You could even do these doors if the roller shutters aren't too heavy. You can do them with cold formed lip channels, provide little openings for them to go through. Or you could build up the brickwork in this area and just build the door in brickwork. Sometimes it's neater having your doors in brickwork rather than steelwork. And yes, then you'd go through all these details and add the last information. Now we're going to go back to our drawing. Now that we've got all that, let's have a look at a couple of things we might want to do in terms of finishing off our drawings or double checking or making sure that if, for instance, often a steel draftsman will draw the one, a concrete draftsman will draw the other, to make sure that they tie up. There's various useful tools that you can do to do that. What we're going to do now is take this layer, or this whole roof layer, and drop it on top of our foundation layer, just to make sure our columns are in the right position, column sizes are correct. But you could do that with a lot of things. You could do that with surveys, you can do it with mechanical engineers' layouts, architects' layouts, etc., where you overlay one drawing on top of the other. So what now I'm going to do is click and select this, press Ctrl-C to copy, Yes, and then I'm going to paste it as a block. Control Shift V. Activate the window again. Control Shift V. So I think my computer did something as I copied it. So let's do that again. Control C. There we go. Control Shift V. Oh, it's not working today for some reason. I don't know if I've got too many commands activated that it doesn't want to paste as many items as that. Ah, there we go. Now it's working. There we go. So I've created a block of the entire roof layout. What I'm going to do now is create a layer called overlay. Oops, catch that overlay. Steelwork. And I can take this. If I wanted to make it possibly stick out, I could even go into this block and make it all magenta or pink or some other color. But what I'm going to do now is move this firstly to where I want it to be. And find a nice point to overlay it. Oh, otherwise, if you sometimes can't find a nice cross, what you do is you just move grid line 2 to match up with grid line 2. And then select your block again. Then you move it horizontally such that it matches up with the grid lines in the other direction. Move J to tie up with J. Oh, wrong way. Move M, enter for move. Alright. Now we've overlaid our steelwork on top of our concrete. So now I'm going to change it to the layers overlay steelwork. Overlay steelwork. What I want to do now is lock that layer. And you'll see why I want to lock it when it's been done. So I'm going to go here, there's lock, overlay steelwork, and I'm going to lock that. Once you've locked something, it goes very faint and sits in the background. So now also I can't edit. So if I'm drawing here, I can't delete it. I've selected now, but I can't actually delete that layer. I can't edit it. I can't do anything with it once it's locked. So I can go through now and check what's happening with these layers. So I can go see, oh, you can see I've drawn a different size column for these two items. So with that overlay, you can quickly check if there's things you need to adjust. Biggest things you'd go through and first check that all your columns are in the same position. For such a simple warehouse, that seems quite trivial. If you've got a very complicated job, you need to make sure that everything ties up exactly, especially the shopping centers where you've got things all over the show and at different levels and heights and such. You'd want to go through and make using overlays that everything ties up. There's other ways to do it with XREFs and other things, but for now we're just going to use a simple overlay and such. Alright, so you can now, with this overlay, quickly check all your details. Or what you could do is before you even start your foundation or your roof layout, put an overlay underneath and just simply draw on top of it. Because this is quite useful that you can draw, you can still use the snaps of the layer that's turned off. So you can go into any area and draw around it and draw on top of the layer. And then when you don't want to see it anymore, you go back to your overlay, you freeze it, and it's gone. It's still there, so if we ever want to make further changes in the future, we can unfreeze it and we can edit it again. At least that's a very useful tool for interfacing your concrete and steelwork. Right, so that's another useful tool you can use, and that's generally taken us through most of the details required for steel drawings. Then now we've been through concrete drawing requirements. I'm just going to see if there's anything else you might want to put on a concrete drawing. Just make it clear, especially with concrete, you'd want to add sections. So I'm going to go have a look for some sections for you. There you go. So this would be section KK, section HH, all these sections, and you'd need to make sure wherever you put the section, it's K, and it's on roof RF01, and then you can go to RF01 and find all these details. So you tell them on the drawing where to find the section, what the section is, and then you go to the section and it's got information that might not be immediately clear on your drawing. You can put layers there, levels there. And this can be drawn in the same way that we did our section projected this, where you use your section to project across and create your plan. Or if you've got a plan view and you want to create a section, it's very easy to do that. You put this down, you rotate it, create it as a block, project lines, and you can quickly create sections. This is a section created at the entrance where we had to put a little ramp into the building and the lights. So that covers then a lot of the general details in terms of finishing off your drawing and providing what's required. I'm just going to have a look at our list, check we've covered everything in this lecture. Concrete layouts, base details, we've had a look at column details. We've looked at tying concrete and steelwork together, and overlays and layers. Just to have another run through of layers, since they're so important, we discussed previously, but here is your, if you click up here again, there's your layer properties. It's got all your layers inside, all the different colors, line types. You can edit line types. You can, however, manually change layer information outside of this. Let's say I've drawn this, and this is currently on brickwork. You can see now, this, even though this is brickwork, I can manually change it to be on another color. Because this was a steel drawing and didn't want to emphasize the brickwork, made it on a much thinner color. Remember, this is our thicknesses here. Red is very thin, whereas cyan, green, etc. much thicker, so it's on a much thinner color here. So what you would do normally is you can play with this color in this block. So if I wanted to make that whatever color I want, I can select it there. Need to undo that, Control Z. Could even change the line type of an individual line rather than a whole group of lines. And you can select your line type there. You might have to just adjust the line type scale to get it to display properly. You can adjust the thickness, though normally when you plot it, if you're using a CTD file, which we'll learn about in a lesson or two's time, our line colors map to a specific thickness anyway, so that normally doesn't affect drawings as much, but there are ways to set it up such that your lines plot with specific line thicknesses. Right, so that covers the rest of finishing off our drawing and starting to create concrete layouts. Concrete layouts are normally simpler in terms of setting up beams and columns and the likes, but they become much more complicated when you have to add in penetrations and services and all sorts of things. You'll see back there. Yeah, and you've got all sorts of other little details, and when you're putting in all the bending schedules as well, those also get more complicated. So yeah, so that covers our lesson for today with all the information. What we've still got to cover now in our lessons is then covering setting up our title box and pages and plotting, all the plotting specifications and details, and then there's also just some miscellaneous tools and useful things to know. So we'll cover those, and then we'll be more or less finished, and you'll be ready to draw. All right, thanks a lot.